communication resources, and faster and more reliable
technology.
Higher performance communication resources, and faster and more reliable.
This is the Hackinabox. Can you hear me now? Okay. Thanks, everyone. This is a self-contained pen testing lab, so let's get started. I'm Marv White. I'm a network security analyst for a local healthcare supplement company. All the requisite certifications that everybody has, and I like to say that I collect hobbies as a hobby. I tend to jump from one thing to another, and this is just one of those projects. So today, this is what we're going to talk about. We're going to go over what the Hackinabox is, how I came around to do it, kind of the idea, where I'd like to see it go, the problems that I ran into when I was building it, the challenges that I was able to overcome, some of the decisions that I made. I also want to make it better, and I invite anybody who's interested in this, just let me know. I'll be happy to take any input, particularly if anybody wants to help build some labs. We'll go into what all is in the kit, and there's really nothing of value in this talk, so I just want to set that bar really low to begin with. It's not going to go over how to use Kali, any specific attacks, anything like that. This is more the framework that you can use to learn how to build one of these to help teach other people. Mission statements. Gotta love these, right? Reason that I wanted to do this as the project evolved was I'd like to have something that you can take into a classroom. You can give to kids, to a hacker camp, or a scout troop or something like that, and give someone the beginnings of this is how you do some pen testing. Get people interested in infosec, into security in general. I was going to have a really great quote here about standing on the shoulder of giants, but our keynote kind of ruined that this morning, so I'll skip that bit. But yeah, let's get the next generation of infosec professionals the tools to get interested, to learn, to jump into this. You know, I find security fun for a reason. I'd like to see that interest for other people too. Again, I want to make sure we're setting the bar appropriately here. But a little bit of backstory. About 1.5 years ago, I was studying for my Certified Ethical Hacker cert, and had an introduction into, it was Backtrack that we were using, but it was kind of my first foray into the offensive side of security, having been kind of blue team defensive side for most of my career. I decided I needed a lab so I could use some of the tools that I had been learning and have a way to kind of work with what I was using. Also, I am innately curious and just wanted to kind of dive into that. You know, self-education is a recurring theme amongst people of our profession, so this was just a natural progression for me. Originally, my idea was just to use VMs. There's a ton of them out there. You know, you can go get Kali directly from offensive security, and a VM app already ready to go out of the box. There's Metasploitable, things like that. So I started looking around my house. What hardware did I have that I could use to build up a hypervisor and set up some VMs and set up a lab? Well, I didn't have a whole lot. The only spare machine I had lying around used old DDR2 memory, which was just stupidly expensive when I started this. So started to think about, you know, what else could I use? What could I do to build this out? And also, you know, when it comes to setting up a pen testing lab, you're running vulnerable systems, intentionally vulnerable systems. You don't want those running on your corporate or on your home network. What if someone else gets to them? Then they can pivot around and attack you. So I was also looking at ways that I could protect myself. I'm no VMware expert, so I didn't really feel comfortable setting all this up on my home network. That's when I came up with the Hackinabox concept here. It's all Raspberry Pi based, and really the reason that is I was looking for an excuse to play with Raspberry Pis, right? They're cheap, you can get them very easily, and so I picked up a couple and started setting it up, and then I got the idea, let's throw it all in a box, a literal box. Let's have it all self-contained where it's portable, and then that's when the idea of this is something more than just for me. This is for other people to play with. This is for a different audience, right? And in talking with a bunch of colleagues about it at work, it kind of evolved into this idea, let's have this standalone, self-contained system. Let's use it for more than just my own little personal lab. Let's start teaching other people with it. So how do we put it together? You know, obviously, step one, you have to cut a hole in the box. And that's just where I'm running the power to. For the display, I looked at a few different options here. There are some little mini HDMI 7-inch displays that you can get. They're a little spendy, also pretty small, so it was kind of hard to see. I was poking around. I think I ran to Walmart with a coworker, and I saw this TV. I'm like, wait a minute, that's cheap. That's HDMI. This will work. So I picked it up, and I had already picked up this toolbox. So I take it back to the office, take the TV apart. It magically fit. It just happened to wedge perfectly in there. I decided, you know, okay, this is now a thing. We're going to go. That was the original concept, which we'll get into a little bit later, and I ended up landing on this gaming display, which was significantly smaller, but I was able to Velcro it in, which means I can pull it out if I want to use it for something else. Stuck the Raspberry Pis together. Everything's just kind of Velcroed in, so you can pop it out at needed or at will. The power supply's in there. Had an old tackle box lying around that I took some of the inserts out that I used for storage internally. I was running into a problem where I was running out of space internally in the case with all of the cords and power supplies and everything. Had a full-size keyboard, full-size mouse, couldn't fit that in. So it changed again over the course of the evolution. Software-wise, pretty basic stuff, running Kali Linux on what I call the attack server. And that's what you do all of your interfacing through. The victim server, I'm just running a real simple LAMP stack. For anybody who doesn't know, LAMP is a Linux, Apache, MySQL, and PHP, all off-the-shelf stuff that you can download from apt. And then for the victim service, I'm running DVWA, the Damn Vulnerable Web App. And this is an application that you can run that has a number of different vulnerabilities baked into it that you can attack at will. As I said, again, this is kind of a useless talk. I'm not going to go over the intricacies of DVWA. But that's what I decided to use software-wise. And all of this is openly available free from the various vendors. There will be links later in the slides. This is what it looked like to begin with. There's a fair little spaghetti monster with all the power supplies, power cords, network cables. It was using a switch, just a little, I think I used a Netgear 4-port switch initially. And at one point I had as many as 3 victim servers that I was going to run. But I decided to pare it down just for usability's sake into its current form. And this is another problem that I was running into. You had giant wall warts for everything. You needed one for the switch, one for the TV, one for each of the Raspberry Pis, and they take up a significant amount of space on a power strip. As you can see there, I've got one little slot that I might be able to wedge a plug into if I was lucky. And this is only running with one victim server and one attack server. It was kind of hard to keep things tidy or elegant inside the box. It was a giant mess of cables and everything, and I wasn't real happy with that. And so obviously I decided I needed to change it. But this is what the original display looked like. As you can see, it just fit right into the edges of the toolbox I'm using. The downside of this is that you can't reach the power or input buttons on the side of the display because they're obfuscated by the case. So you had to use the TV remote control, something that you could lose, batteries could die. You know, I didn't really like that solution either. And also, that giant power brick was really kind of was harshing my vibe a little bit. I couldn't make that fit into the whole case in a way that made sense to me. And so I started looking for some other solutions. And so this is kind of how the whole kit evolved over time. Originally, when I started this is about 1.5 years ago, I used the Raspberry Pi B Plus and a Raspberry Pi B that were the original ones that I had. And then a few months later, about 1 year ago, the Raspberry Pi Foundation introduced the Pi 2, which, if you know much about them, I think the Raspberry Pi 2 has about 6 times the CPU as Raspberry Pi B, 4 times the RAM. It makes Kali usable, because in the old ones there was a Kali image for it, but if you got into X Windows you could hardly use it, so it was really only usable from the command line. So that was the first change. Then just last week, Raspberry Pi 3s were announced. This currently isn't running those. I don't have images yet for those, but that's for future engagement. For networking, again, I was originally using a small Ethernet switch. I wanted to simulate actual attacks where you're going from one host to another, which is why there are 2 separate boxes in this. And so I felt it was important to have some kind of networking, and that's why there was a switch in there. But again, it's another big wall wart on the power supply. And it just was kind of ugly, so I didn't like it. So I switched to Wi-Fi. There are small little USB-powered Wi-Fi routers that you can get. They're designed for hotel use when you're on the road, so you can hook up to the hotel Wi-Fi. You can connect multiple devices that way without having to pay for it, that sort of thing. I used that for a little while, but I found them to be quite unreliable. They're not really designed for 2 devices to talk across them. So then I just decided, let's just use a crossover cable. Let's keep it simple. And that made a great deal of sense. Also, I stole the cable, so hey, it's free. Thanks 801 Labs for that. Thank you. I also have multiple victim services set up, and that's something that I still want to do, but I think I'll tackle in a different manner. Again, the victim service just uses a lamp stack. I investigated for a little while the Windows 10 IoT image for Raspberry Pi. There's some drawbacks to that. One, it's not really running Windows 10. It's effectively a sensor. You have to connect to it from another Windows 10 machine, a laptop or a desktop or something. It doesn't run any real services. I just felt it wasn't a good fit, at least at this time. It'll be interesting to see as the whole IoT world evolves if they improve the Windows 10. I would like them to improve it enough that it can run like a little stripped down IIS that you can then bust and own, because I think that would be kind of fun. But right now, it's not usable enough to be a good victim server for this. So, and also space, that would have been another Raspberry Pi. And my wife was starting to look at me a little weird when I had half a dozen Raspberry Pis kicking around the house. Well, what are you doing with all these things? So I trimmed it down a little bit. So what do we have today? And you can come up and look at it later. So right now, there's 2 Raspberry Pis that are just Velcroed together, and then to the case, crossover cable together with a USB power supply. Everything in this is running off of USB. And again, the little storage bins I just took out of a tackle box that I have. So in this, I've got a little storage for memory cards, et cetera, and I threw my lockpick stuff in there, which I think will be, that's a fun little tool that you can use for when you put this in front of a student. You know, it's not just information security that we care about. We care about physical security too, right? So let's have the lockpicks in there and teach people to be interested in lockpicking. That's all part of what we do. So it's not really factored into the cost of this, but that's why I have it in the case today. Just I think it's a good corollary to the rest of the kit. As you can see, the gaming display is up there, and I'm using a wireless Logitech keyboard mouse combo for I/O. And again, everything that's physically attached to the case is just using industrial strength Velcro. Just go to your craft store and find it. It's pretty easy to get. So Raspberry Pi 2 for the compute side, and this will change to Raspberry Pi 3. That was just released last week. I have a couple of these. The SD cards, I just tried putting the SD cards in to see if they would work, and they won't boot. So the Raspbian, the victim server is pretty easy to set up because you're going to do all that through Raspbian or Noobs. The Kali, the offensive security hasn't yet released an image for Kali. I understand that there's a script that you can install with that. It's not part of this because I haven't done it yet. Everything that I've got here I know works, so I can only speak to that. But that's the next step of this probably is going to be the Pi 3s. Again, running the Kali ARM distribution for the attack side. The toolbox I just picked up at Harbor Freight. It was real cheap and gave me an excuse to add the fuzzy handcuffs for added security because I thought that was a fun little thing. And everybody that I talked to about this wanted the nuclear bomb code handcuffed to your wrist toolbox, so that's in there. The display I'm using is from Gaines. Thanks to Grifter for telling me about that. That solved a few problems for me. And then the power source is from Anchor. And I'll get a little bit more into the power supplies because I did run into some issues there. And then the bonus stuff in here are some practice locks and lockpicking, lockpicks. I still have the USB Wi-Fi stuff in there, so if I'm out somewhere and I need to upgrade a package or something like that, I've got that connectivity, and you want the fuzzy handcuffs on this. That really just kind of seals the deal. So the problems that I ran into while building this, one of the first things when I built the final form or current form of this was finding reliable USB power to run everything. You'll have to find one that works. I went through about 3 that didn't. I would plug 2 or 3 devices in, and when I plugged that third device, it would dump. It wasn't able to provide enough power on each USB port to actually power the Raspberry Pis, the display, the Wi-Fi. That was probably the biggest challenge when I decided to power everything via USB was to find a reliable power source. The power on procedure. Kali is very picky about both power on and power off, I've found, at least in this setup. So you do have to power on the display first before you power on the Kali box, otherwise it never picks up the signal from the HDMI. And also when you're powering down, if you don't gracefully power down Kali, it will more than likely corrupt and you're going to be rebuilding your Kali box. Ask me how I know. This happened several times. I think I wore out a couple of micro SD cards. The Wi-Fi was very inconsistent. I could make connections from the victim or from the attack server to the victim server. I was able to kind of proof of concept that, but not reliably. Probably about 75% ping loss when I'd just be running ping. And it very well could be the router that I have. I only tested one before I decided to dump it as a concept. I want to look into that further because Wi-Fi hacking is part of our daily lives now. So I'd like to find a better solution for that going forward. Also, the Raspberry Pi 2 has a fun little, it's not really a bug, it's just physics, but if you take a picture of it and you're using a Xeon flash from your camera, you just rebooted your Raspberry Pi. There's a couple of fun little articles about it I'd recommend that you'd watch or read up on. I don't know if the Raspberry Pi 3 is susceptible to this. The older ones are not, but I think all the Raspberry Pi 2s definitely are. So it's just something to keep in mind. So if you do like I am and you want to take some pictures for your presentation, you're going to be reinstalling Kali because we're going back to the other problem that I was talking about. Ran into that a couple of times. And if you use the TV, and there's some valid reasons to use the TV rather than this gaming monitor that we'll get into, don't lose the TV remote. I did for about 3 weeks. Wound up under my couch. Got to thank my dog for that one, I guess. But so just, I didn't find a good solution for that. If you build one of these, I'm sure you can find some way. Maybe, hey, Velcro it. I used a ton of it in here. So for the proof of concept, finally got all the software up and running and downloaded a lab from Googling DVWA walkthrough because I'm not going to reinvent the wheel there. And started just running through the exercises in that. One of the first things that I ran into, the current release of Kali for Raspberry Pi at least does not include some basic packages, specifically curl wasn't in there, and half of the little walkthrough things you were going to use curl. You could probably use wget too, but so you may need to install some packages yourself. And you don't absolutely have to use Kali for this. You could use Arch Linux and do Black Arch and something like that as well. But again, I've only tested this with Kali and with DVWA. And I think the problem that I ran into is the lab that I was using actually was based off an older version of Backtrack. And so when they changed from Backtrack to Kali, they changed some of their base repositories, I guess, and that's why curl wasn't in there. So that's something that you'll need to do. But a lot of the labs work, because some of it is just URL manipulation for password changes, things like that. I mean, that's the level that this web app is designed for, is intentional vulnerabilities, and there's different levels of security that you can set the web app to, and then the lowest ones, it's using the dumbest security practices that you can. And so sometimes you're just doing URL manipulation. That stuff is working. I didn't go through everything on the labs that I found, but a lot of the walkthrough stuff that I found worked. And to go forward with this in the future, I definitely want to see labs that are really on rails that you can put in front of somebody without any background in this, and they'll be able to do a lot of this. Again, if you have any interest in working with me on that, please let me know. I want to make this a more full-fledged product. Going into the improvements. I want to find better, or more, I should say, victim services. I'll throw together maybe an FTP service or something like that that you can pull some passwords out of with a TCP dump or something like that. Just other victim services I'd like to see other than just DVWA. Metasploitable, which if you're not familiar with, is an intentionally weak system that's an OVA that you can download. It's a VM. I'd like to see that, something like that ported to this so you can use Metasploit framework to attack it, because there's tons of labs out there for that as well. Also, because who doesn't love Lego and 3D printers, I figure instead of using just off-the-shelf cases for the Raspberry Pis, throw together something with Lego that you can connect both of the Raspberry Pis together, or 3D print something. Again, I want to make a better guided lab. I want something that is very approachable to a young audience. I really feel that the end goal for this project is something that you put in front of kids, a high school computer class, or any group of kids that might be interested in this. And so the labs need to be better geared for that. Most of the labs that I've seen are more geared for people with a little stronger background. The Raspberry Pi 3s. Raspberry Pi 3, one of the big improvements that they added is it bundled Bluetooth and Wi-Fi onto the board, so you don't need to use external cards. And then you can get into some of the wireless hacking stuff, and let's see some C-sploit on this and see what you can get there. Do some Bluetooth hacking, that might be fun as well. I haven't tested it, but I'm pretty sure that with one of the beefier USB battery packs that's out there, if they can jumpstart a car, they can probably power this for a little bit of time. I want to make it battery powered for real portability. So right now, everything's running off of one plug, which is great. But how about 0 plugs? I think that'd be even better ultimately. It does drive the price up on this a little bit, but it would give it that portability that you could take it out. It doesn't matter where you're at, you'd be able to run everything. For the attack server, Kali's not the only one out there. With Arch Linux, you can install a Raspberry Pi image and then download all the Black Arch packages. It requires a fair bit of space, so you're going to need, I think, like a 32 or 64 gig SD card, where currently I'm running off of just 8 gigs, bare minimums necessary. That's somewhere that I want to investigate further and go in the future. And any other improvements that anybody might have to this, please let me know. One that I'd also like to see is to ruggedize the Raspberry Pis to a degree, right? The Raspberry Pi, as it comes out of the box, is just a little card. It's pretty easy to break if you really wanted to. I know that Hackers for Charity has their Rugged Pi project. Something like that might be a direction that I go in the future, or even just looking at ways myself to ruggedize these. I think that, again, lends itself to the portability aspect of this, making it easier to put in front of other people. And the sky's the limit on this as far as where it could go, particularly on the victim services side. There's millions of applications out there. A lot of them run on Linux. There's no reason they couldn't run on the Raspberry Pi. And I really think that a lot more work can be done on that side. And that's where I'm going to work in the future. Also, there are ways that you can cut prices on these. I want to make this approachable and affordable for people to build. And there's several places that you can cut significant costs out of this. The original TV that I was using in this ran about 99 bucks. And that was, the display is far and away the most expensive part of all of this, by the way. The gaming display that I'm running now, that was 170, so you can save significant costs right there. There are also some other USB displays out there. I started digging around to see if I could find alternates to this particular one, and I found them for 100 to 150, and there may be others. Go to some sketchy Chinese site, and maybe you can get a knockoff of this for 75 bucks, I don't know. You can run your victim services locally to the Hackinabox. You could install the same lamp stack that you do on the victim server, install DVWA, set it up, and then you're just attacking against localhost. That removes half of the cost of the computers that you're using in this, right? You can use the Raspberry Pi Zero. Raspberry Pi Zero came out 4 or 5 months ago. It runs $5 instead of the $35 or so for the Raspberry Pi. There are some extra complexity to that because it doesn't have a built-in network port, so you'll have to use like an OTG cable and then a network adapter. It's a little bit more as far as moving parts, drives the price up a little bit more because all of the peripherals for the Raspberry Pi Zero cost about as much as the Raspberry Pi Zero. OTG cable is the same amount, case is the same amount. But it's also there. You can omit the toolbox. You don't need it. I just felt that it was kind of a fun little gimmick and kept everything all self-contained. Save a couple of bucks there. Also on the compute side, there are alternatives to the Raspberry Pi. The Orange Pi, which is a clone of the Raspberry Pi, is significantly less expensive. I haven't tested it with this. I know for the victim server, it would be fine. Also with that note, on the Raspberry Pi Zero, it would really only be able to run the victim services. It doesn't have the compute, I think, necessary to run Kali or to run a graphical interface in a usable manner, I think. Again, I haven't tested it, but just given the difference in amount of memory and CPU available, I think that would be the case. But as far as the other system on board machines that are out there, Chip is one that just came out. It's about 25 bucks. They had a successful Kickstarter, and I'm waiting for mine to be delivered. And I want to test it for victim services. Pine 64 is another one that recently hit the market. Jaguar board is an x86 compatible one. It's about the same price point that hit the market. There are several other options as far as the compute that you can use. You don't have to use Raspberry Pi. I know the Raspberry Pi stuff works as long as you're using Pi 2s. So that's what I'm recommending in this case. For power, the display wants 2.1 amp at 5 volt, and the Raspberry Pi is 1.8 amp for the Pi 2. I'm not sure what the power difference is, if any, for the Raspberry Pi 3. It's a little bit less for the older Raspberry Pi Bs and B pluses. So that's a consideration that if you're going to run a similar sort of USB charger block like I'm running, you need to make sure that you've got that. The one that I have is an 8 amp 40 watt charger. It's from Anker. I think they've upgraded it, and the new one is obviously a lot more expensive, but this one's still available. You can find it on Amazon. You can find it on eBay. If you want the USB powered, if you want the one plug solution that I've built here, that's going to be keys to make sure that you can power it correctly. To steal a phrase, I found a lot of ways to not power this, so keep that in mind. For the parts on this, this is basically the build sheet for this. 2 Raspberry Pi 2s with a case. They run about $45 for the case, 35 bucks for a Raspberry Pi 2, about 10 bucks for the case, and then you can find some deals. The new Raspberry Pi 3 might actually drive that price down a little bit. Seemed to be the case when they introduced the Raspberry Pi 2. So you can save 10, 20 bucks there maybe in the next few months. A couple of micro SD cards, about 8 bucks a piece. You want good micro SD cards. I found that out as well. There's Class 10 and other Class 10, and so buy something that you know from a reputable source. The toolbox, picked it up at Harbor Freight, about 25 bucks. It has some internal pockets that you can rip out, which is what I did, where the display happens to be monitored or mounted. But there are some options there too. The display is a gaming display from Gaines. They run about $170. It's the most expensive part of this. And as I said, that's also probably the biggest opportunity you have to cut costs, is to use a different display. You could set up everything else the same and just take it into a place that has a TV or a monitor you can plug into and get the same results. So you don't have to have it like this. You do have some options there. Picked up a couple of little 6-inch micro USB cables just to limit the cable mess inside the box. They're a couple bucks. Stole the Ethernet cable. I highly recommend doing that wherever you can. Ethernet cables, you shouldn't buy them. HDMI cable, it's a little 1 foot, I think, HDMI cable that was $8. The Logitech K400 keyboard. It's a really great keyboard. Last week, or the week before, somebody disclosed some nice vulnerabilities for that. So if you do buy any wireless, non-Bluetooth keyboard, go see if it's one of the affected ones. Upgrade your firmware. If it's a Logitech or a Microsoft, they're the only two vendors I've seen that have upgraded firmware for it. Something to keep in mind. Who knows what we're going to see attacks against next. I was a little surprised to see that one. Well, not surprised, but a little dismayed, I guess. Everything that you see here, save the USB router and lockpicks, I'm in under 370 bucks. So for less than a price of a laptop, you can build all this, and it's really extensible. You don't have to build a Hackinabox out of this. You can build like a little RetroPie gaming machine out of the same stuff. Get some value out of it other than just my silly little project. Software, everything, again, is open source or freely available. The victim server runs Raspbian. In my case, I'm lazy, so I installed it via Noobs. Noobs is the official Raspberry Pi method of creating the images on. There's a Noobs for Windows. There's one for Mac, OS X Mac. Or you can just image a card with DD or whatever. There's various different ways you can do that. Kali Linux for ARM, you can get from Offensive Security. If you go to kali.org, you can find a link to the ARM images, and Kali recently upgraded their image to the new rolling release for Kali that they use. And then DBWA is from dbwa.co.uk, and that you just download the zip file, you extract it, and you run some and put it into your website, your web server index page directory, and you can run it very easily. There's very little setup for that. I think basically the configuration, you put in your MySQL password. It's pretty simple. I'd like to say thanks to a few people. Pope for helping me take that stolen cable, make a crossover cable out of it, because I suck at cables. Grifter for telling me about this USB gaming monitor. That really solved my power problem quite a bit. DVWA for making a web app that made this really easy to set up. Condor, you know what you did. My wife, Ka, and the B-Sides Raleigh crew for convincing me to come up and talk in front of you guys today. Any questions anybody has, please let me know. It's a GL, it's right here, GLI, I think. It was pretty inexpensive, sorry, GL iNet is what it is. Pretty inexpensive, very unreliable. If I was just pinging across to a website, I'd get no packet loss. But when I was going from host to host across this, tons of packet loss. This needs a little bit more investigation on my part to see why, or if there are other options for the wireless. There are a ton of these out there at varying price points. This one is cheap because I'm cheap. So GL iNet, avoid for this. But it is handy to have. In a case like this, if I was going to do a live demo, which I'm not quite stupid enough to do for my first ever talk like this, it would be nice if you could download updates or something like that if you needed to pull a package. It's really good for that. You can get online very easily this way and safely. But I know there's got to be a better solution for the wireless, and I'd really like to see it go that way, particularly with the Raspberry Pi 3 with built-in Wi-Fi. You don't need to add another Wi-Fi card to the mix. Anything else? About a year and a half, but let me qualify that. I had 4 surgeries in that time, so there was a lot of downtime that I was not paying attention to it. I'd probably say I'm in 30 days of real work over the course of the last year and a half of finding the services, putting it together, taking it to 801 Labs and getting input and stealing ideas from other people, things like that, and cables. Jeffrey?
So, from a hardware point of view, switching from the Pi 2 to the Pi 3 is basically just a matter of unplugging.
Yep. But from the software point of view, you will have to rebuild the services. And at least as of the day before yesterday, which is the last time I looked, there is not an official Kali image for the Raspberry Pi 3. But I understand there is a script that you can run to download everything and build a Kali image on top of Raspbian. Not yet. I don't suspect there will because of the limitations of USB 2 power. It's not a USB 3 power supply requirement. And I just plugged it in. When I was testing it, I just plugged it directly into my existing infrastructure, and it works. You know, I can install Raspbian on it and get it to work that way, but I haven't run any scripts to try and build Kali or anything like that yet. But power-wise, no, there should be no differences. Yes? Don't know. I'm an old school networking guy, so the first thing that came to mind was a crossover cable. I don't think they're 10, or I don't think they're gig. I think they are 10-100, so they probably don't. Auto switch would be my, or auto sense would be my guess, but I don't know. Anything else? Anyone? Well, I'll be kicking around up here. I think we've got a few minutes if anyone wants to see it. Unfortunately, apparently someone stole the dongle for my keyboard because it's not in there, and it was earlier. So I can't actually log into my Kali box, so when I power it down, I'm going to have to re-image it. But if you want to kind of see how I've got it all put together, it's all right here, and happy to walk through it. Thanks.